this session, we are going to discuss about how to conduct a backdoor investigation and incident response from zero to profit. And before we start, actually, we have some remote speaker in Hong Kong who get stuck because of the quarantine policy. So maybe we should have an introduction first. So can you hear me, Anthony?
Yeah. We're here.
Okay, you can introduce yourself, huh?
Yeah. Okay. This is Anthony. Then nice to meet you guys. Then sorry that we can't attend to it. You know, there's a quarantine policy. But anyway, then hopefully then our good mate in present on site to present and also we all together to present today for the backdoor investigation. And let me introduce myself. I'm from RIXRL and I'm the RIXCon chairperson. And also I also do the mentor for Best of the Best career hacker program as an overseas mentor. At the same time, I'm the Red Hat Asia and Hack in the Box CFP we board members. I have spoken in different conferences like DEFCON Red Hat United States. And right now I'm doing the final semester for my PhD, part-time PhD degree, focused on the malware and vulnerability analysis.
Hi, I'm Hamon, a RIXRL researcher and current PhD student in HKUST under Taiwan's team. I'm interested in software security, binary analysis, and machine learning. Previously, I presented in several different conferences like HitCon and RIXCon, and I'm also the founding member of Backdoor CTF team in Hong Kong.
Hi guys, this is Alan Ho. I'm from RIXRL and RIXCon as well. So our team is focusing on the penetration test, purple team test, and incident response. And recently, we have come across a lot of incident cases, and that's why we bring our case here to share with you.
Okay, so I'm a setter, and I'm an assistant professor in SMU here, and I'm also got business with RIXRL, so that's why this time I represent them to physically present in here. Okay, so let's get started. Okay, so why do we still need to talk about backdoor investigation, right? Maybe some of you work in instance response, you know that it's pretty standard stuff to do the instance response, right? And we have already got some pretty mature framework from the industry, or maybe we have some existing tools like VirusTotal to do the malware analysis. Then why should we still have a talk like this? Because from our actual experience, we found that actually the existing frameworks didn't work well on this kind of stealthy malware backdoor. So that's why we propose a new framework that's dedicated for backdoor investigation. So now I'll pass to Alan to introduce the case background.
Hi guys. Before we getting into the framework, let's have a quick look on the incident. So our team, Anthony and I, is responsible for incident handling for an online gaming company. The IT team is in Hong Kong, so the development team, and network team, and IO team are in Hong Kong. So due to the COVID-19, most of the staff have had to work from home, and they use SSL VPN to connect to the company network. So it's all good, but until one day, the network team reported that the SSL VPN connections got some weird stuff. There are some unauthorized verification of the firewall rules, which happened in the midnight. So our team started to investigate this case. And after a month, another alert was coming from the IS. So let's take a look for the investigation. So for the SSL VPN issues, we interviewed the network engineers and the system admin. And we knew that there were no tasks during that day or during that midnight. And we also looked into the log on, and we found that there is a log on of the attacker in the Active Directory, and then they try to access the firewall admin dashboard in that desktop. And the network engineers has no idea why their accounts were compromised. And we also asked them about the authentication, and they told us that the firewall admin account, there were no 2FA. And the SSL VPN authentication got no 2FA neither. So we look into the SSL VPN device, which is the FortiGate. And from the log, we found that there was a non-Hong Kong IP address connecting during the midnight. And then we checked the SSL VPN from the web UI. We found that it could be accessed from the port 1043. So we tried the famous SSL VPN exploit CVE 201X13379, and we successfully exploited the device and got the credentials from the device. We got the accounts of the staff of the company. So for many cases, the staff like using the same account for SSL VPN and Active Directory. So before we do the third exploit, we look at the stuff from the Splunk. So we use the blue team technique to check the Splunk logs, and we try to take a look on the traffic logs for the SSL VPN. And there were some spikes of bytes received from the suspicious non-IP address. So normally for the SSL VPN, if you establish the connection, it will produce quite steady traffic. However, during the exploit, since the attacker can get the credentials, the bytes received were much higher than usual. So take a look at that graph. You could see the spikes on Friday and the first day in the graph. There are some spikes. And we realized that the attack could happen during that period because the attacker got the credentials, and so the traffic of the credentials was much higher than normal. So after we confirmed the SSL VPN exploit, we try to do some further analysis for the exploitation. So we got the SSL VPN credentials that we tried that on the Active Directory. And we're lucky we found the IP address after the network discovery and got the AD. Then we tried to scan the ports, and we found that there were over 5, so SMB. So we tried to do the internal boot attack. And then we also got into the Active Directory server successfully. Then you can try to create some accounts. You could see the NHO and NHO2, and it shows that we could really own the Active Directory.
You could see why the client is still got the internal boot. So you could see that a company they focus a lot of business, but they didn't update the server more regularly. So that's why some still suffer of this vulnerability.
Yeah, as you can see from the first line, it is still using 2012 R2 server without any patches. So we could run the internal boot exploit quite successfully and own the server. We created the accounts, and even we put the pong.txt files in the server. So let's jump to the first conclusion. So we found that the SSL VPN exploit was successful, and it could lead to the internal network intrusion, and the AD could be owned as well. And you could see the account of the pong.txt. Then for the lateral movement, we believe that the attackers could also compromise other important servers. So for this SSL VPN exploitation incident, after a month later, we found there was another hacking activities. This time it is for the IIS server. Because there were 2 IIS servers, here we name it as O1 and O2. And the O1 IIS server is the infected server. And the IIS server O2 was a new server to replace server O1 after the hacking activities. But then we found something strange. So that entities to continue.
Yeah. How can we hunt the backdoor? You know, sometimes the backdoor is not just hunted by maybe externally or internally. You don't ever know who is trying to compromise the system and who is working on it. However, it's very interesting for that. First of all, as Alan mentioned, the IS Service 02 is a newly installed server. Engineers find some error, holding errors in the morning, and they report to us. They find that there's a module, there's a DLL, transstatic.dll, cannot be loaded successfully to the IS web server, and keep folding or keep doing our error message out. So that's why it really make an alarming message to us. What's happened? All right, it's not normal. The engineers report they installed the new server for the IS, but just cloning, just copying the same configuration files from the affected server, infected old server. But the IS error implies that DLL was missing and could not be loaded in the IS web server. So we try to check out what the DLL, what's going on with the DLL, what is it actually? And from the screen, we capture from the rectum server. You can find that the DLL called transstatic.dll. It looks like quite weird to us. So we checked a little bit some metadata, the properties data. On the left side of the screen, you can see the malware and the backdoor, and the right side of the normal properties data. You could find that typically for the malware 101, you could find that the description and even the vendors or some information of the executable is missing or not correct, inaccurate. So it looks like suspicious, the file. That means it's not a legitimate library files should be in the system, okay? And after that, we try to trace the event as well. And the DLL was attempted to be unloaded, but not successful, all right? So that's why we have some error message from the event log as well. We try to trace the error for the DLL loading and unloading. We could have found the malware in the server 02, but only find the server 01. But the error from the server 02, because the IS configuration, the application host.config tried to load the malware DLL file, I mean the transstatic.dll, but actually it didn't exist. So that's why it caused the error. So the case, this is how we detect the backdoor when trying to move out to the new platform. All right. So the case summary is about, first of all, it's about the SSL VPN exploitation. Thank you to DevCore and Orange team and to find out this vulnerability. And actually, there's many organizations by that time still vulnerable for the SSL VPN vulnerability. And also the Active Directory exploitation, the administrator accounts are created by the attackers. Also, we assume the attackers also can access the network engineer's desktop by the same password with the Active Directory and SSL VPN, because their configuration simply just use the same password, same account. And they create temporary domain account to sublog in. And also the firewall administrator, the console password was saved in the browser. They didn't do any remove it, the cache, simply keep it as a remember me. So they do the lateral movement with the IIS backdoor and keep accessing the database information and change the information. After that, I and Alan to ask and work with the infrastructure team to apply the two-factor authentication and also the patches for the firewall and the servers. That's how we try to do some remediation. But the issue is, we also is a firefighter, all right, firefighting at the front line. But we also looks like a catch mouse, like a practice. It's not really good for us. So we are very reactive in our role. How can we be proactive? This is why we want to do the research, or why we are here with Seta and also Alan and Ken to do this kind of research. Hopefully we suggest a systematic way or model to detect some stealthy attack that is not commonly detected by some detector or antivirus detector. Maybe some of the talks, a lot of talks, technical talks, will go into the deep analysis of the backdoor. But as an incident responder, we can't talk to the client, say, hey, give me 2 days to find out the backdoor, what's going on. They need some immediate reaction. For example, any machines are still infected with the backdoor, any more malware, what can we do? They ask these very critical questions. Okay, so that's why we didn't do deep analysis at the beginning. It requires an enterprise with more afford more resources to do the deep analysis. So we propose a more lightweight analysis and detection. And most likely, it's a lightweight. I've seen a lot of academic research or even some medical one, which simply just upload to the public sandbox for analysis. This screen is was just captured yesterday. We simply check our hash and even upload the transstatic of DLL to the virus total. We've uploaded since 2020, and we analyzed at 2021. And also we do the analysis yesterday, just for detector can still detect this backdoor. And there's some Java rules detected, but these are very common features, cannot be figured out. This is a backdoor. So that's the reason we come to our playbook. This term is quite good for that. I'm thankful to our review board members, Lydia and also Milka, to suggest this is a playbook about the backdoor analysis for detection. And typical antivirus and sandbox cannot be identified highly customized and target attack backdoor. We try to establish methodology to detect the backdoor, threat, and playbook for incident response. Much more efficient, much more focused, flexible to plug and play for the methodology. In our methodology, we have 3 different components. One is the detection and analysis methodology based on rule-based, statistical-based, and artificial intelligence-based. Another is the algorithm, how about detect for the investigation of the backdoor. Another is the detailed matrix to do the investigation for the backdoor. Ken and Seta will explain about it later on. For the detection analysis methodology, we simply got 2 major areas. You are very familiar with these 2 areas. First of all, is static analysis, one is dynamic analysis. Dynamic analysis is very popular. You simply use some like Google Sandbox, any.1, okay, to find out the sensitive API they are calling. But for the static analysis, most likely, for example, we can use the LSH to compare the similarity and Java rules to detect the pattern. But in this stage, we do more on string and frequency-based analysis and AI-based analysis. Of course, you could do the entropy to detect the obfuscation, the level. All of the techniques are already published. It's not talks about locality, but how can we combine different published techniques to detect this kind of stealthy attack? For example, we are doing the string and frequency-based, we detect the frequency, all right? The AI-based, then I'm going to explain about it. For the string and frequency-based backdoor indicators, we try to, first of all, extract the string with the length larger than 3 from the binary. Our parser will try to attempt to classify the parsed strings as SQL, PowerShell strings that are encoded with base 64 or none of the above. Actually, for the SQL and the PowerShell script, we create a character frequency table with example collected from Microsoft and Azure's GitHub repository. So that's why we can have a distribution, statistical distribution to find out what is the normal distribution for the legitimate binaries. After that, we compare with the DLLs or any exe files under or suspicious file under our target folder and check out the frequency. Then we can find out the backdoor got a suspicious high number in the SQL and the PowerShell script, the pattern. That's how we identify it. You know, the very weird point is, as I mentioned, many antivirus detector cannot detect it because they find it legitimate. So that we need another site, another way to detect it. Let me just pass the my time to Ken to continue about it.
So apart from the string analysis already covered by Anthony, we also tried to use AI model to further analyze our sample. As the sample were failed to detect with any AV vendors and also by any endpoint solution during the time we're doing the incident response, we also tried to examine the correlated sample with our in-house malware detection engine we created before in other research. While our model may not be capable to deploy as a real-world antivirus or endpoint solution due to a very, very high positive rate, but in that sense, it generally should be capable for doing some sort of initial triage. And actually, our model works pretty well on detecting some APT samples, as we have done some evaluation before. However, this is a bit surprising that it's only capable to detect one of the sample out of the 5 samples we collected from the server. In some sense, it also shed light on the reason why antivirus and endpoint solution fail to take the samples, as a lot of typical antivirus or endpoint solution nowadays were signature-based. In our cases, the captured backdoor samples mainly composed with a lot of legitimate open source library like the JSON parser or a lot of typical parsers, and actually they didn't employ a very lightweight, or even they didn't. I remember the samples didn't apply to any obfuscation in the static components, and hence it didn't being threatened by the YARA rules at that time or even the antivirus solution. So this is an explanation for why it didn't being detected. After covered with the analysis attempt we made, let's talk about our contribution for this presentation, the backdoor incident response algorithm, or I would say it is a workflow. So as you can see the slides, here is a very high overview of our incident response algorithm or the workflow. We will try to model the overall network architecture as a graph, and we will try to use the vertex to represent the server, workstation, or any devices, and the edges will be used to represent to the connection between different nodes or different devices, where we will try to mark the blue color as the trusted connection and red color as untrusted connection. And then we will pick a target and start our investigation. And we have to check some criteria. For example, in our case, we will try to examine the user authentication and also to look for any suspicious operation. Like for example, the delete, create, execute, delete, create operations. This pattern is a very common backdoor activities. Or we can look for the ratio between the number of accounts authenticated from a node to other nodes versus to the number of account accessed to that nodes. This aims to detect for any possible lateral movement from a certain machine. Apart from this type of typical features, we can also examine the configuration difference from the original coding copy of our server configuration or whatever configuration. And then if any of these criteria matched, we will try to further investigate that machine or that node. One of the good things of our workflow is that it is highly extensible, and we can replace any of the criteria with due to the incident or the environment of our architecture. So here maybe it is a bit abstract to talk about from verbs. Let's give an examples. And here is a very high level overview of our internet network architecture of our enterprise. And the blue color is the trusted connection, as it is some internal stuff. And red edge means the untrusted party, as you can see here. And here is the overall modeling of the enterprise network architecture. And as the incident starts from the database, so we will mark database as our target. And we will try to investigate And we will try to investigate from the nodes connected to our database one by one with the criteria we defined before. And firstly, we will try to examine, for example, we started from our web server. We will start from our web server, like the case, the IIS server, and we will examine for any suspicious authentication and activities appears on this server. And then we will check the ratio mentioned to ratio number of authenticated system connected to different users, and if it is greater than 1, we'll mark this as a suspicious node. And then we'll try to diff the configuration file of this node with the expected golden copies of the configuration. And in our case, if any of these 3 criteria matches, we will set this node as a suspicious node, and then we'll continue our investigation towards other nodes connected to the database. And here is the final result. And basically, we found that the web server is suspicious, and then we will try to mark any outbounding address from this server as a untrusted connection. And as you can see, this become originally is blue, and then now it's become red. And then we will try to investigate other server connected to it. And then we will try to run the set this after we investigate all the address connected to the database. We will try to set this as the target again, and then we'll try to run the algorithm again. And after we collected a set of suspicious nodes, we will try to run the backdoor incident response metric on this machine or these nodes. And in that sense, our workflow can prioritize our investigation resources rather than exhaustively examine all of the machine in the network, which is quite time-consuming and maybe not meets the business needs of clients or the enterprises. So, Seth, let's talk about the incident response metric we come up with.
So we have talked about the case background and how do we do the investigation, and also some of the algorithms that help us to speed up the instance response. So now we are going to propose a backdoor instance response matrix that summarizes these and lists out the different steps and procedures. So basically, we need to focus on 3 dimensions. The first one would be the backdoor or the suspicious backdoored files. And the second one would be the backdoor server or the server that looks suspicious is under attack. And the third one would be the network traffic. So for the backdoor itself, you may get a lot of different suspicious files, and you need to do investigation on each one, right? That may be quite time consuming. But still we want to include this functionality analysis. So usually you may get some errors or reports from the user saying that something wrong with this surface, and then you may take out and see what kind of features. So in our case, you see that the transstatic.dll keeps throwing the errors, so that's why you can find out this suspicious file. And of course, after that, you want to do a comprehensive analysis, like a static analysis or dynamic analysis with the emulation framework. So Anthony, I think you also outsourced this kind of static and dynamic analysis. So how long typically will it take to do a comprehensive analysis?
No, because it very takes time. So that's why sometimes you need set up your own sandbox, or you need to set up your own customized server to load the malware. Sometimes, as like VirusTotal or even the Cuckoo sandbox, it can analyze some common file type like executable. But when you do some kind of very customized or highly target attack, you need to set up your own server to analyze it about it.
Okay, so that means it's very resource intensive, right? But if you have sufficient resources, then of course it's suggest to do so, right? And after that, when you do the analysis, you can write the Java rules with the artifacts that can help you to identify the other potential backdoor servers as well, right? And For a more quick and dirty way to do the analysis on the backdoor, we will recommend these three. So first, we have the similarity analysis. So basically, you can compare the suspicious file with the published backdoor using some algorithms like a similarity check with LSH, or maybe just do a binary differencing. And another way is to do a string and frequency analysis. So basically, you extract the string from the suspicious file. Then you can try to figure out whether there's some hidden commands, or maybe the C2 server's address, or some suspicious strings. And in some cases, the binary may be encrypted or padded. Then in this case, you may need to do an entropy analysis to compare the distribution of different opcodes to see whether it's an obfuscated one. So Ken, I think you are the expert in this area. So what kind of skills or what thing you need to be aware of when you do this kind of analysis?
Generally speaking, I think a large database is the key point to be successful to do this type of similarity matching. As your database, if your database is sufficient large, you will have a high odds to hit a similar, I would say a similar samples. Another point of to be successful for doing similarity analysis would be a better tooling. For example, I would recommend to use the function sim hash by Google Project Zero. I think it is pretty rare in doing some matching, so you may need to play with the configuration to make it more robust by case. I guess in general, we didn't use the default configuration, but we can hit some interesting samples with these tricks. Yes, this is pretty robust. And another model we may consider to look at maybe the graph matching network, again by Google again. This model being evaluated recently in the academic conference, and the results is pretty rare. And I have similar experiments on working on these models, and I guess the results is matched with Cisco Talos results. Yeah, I think this model is robust. But if you want robust, you will need a large database at first. Yes.
And the large database, you need to gather some latest samples, like from the Twitter or from some public malware repository. But however, they didn't do the classification for yourself. Or if you're rich enough, then you could subscribe from VirusTotal, but there's no label about backdoor as a label of a backdoor, as a classification. So that's why you need to classify or to have to dump to prepare a large database as well, or to get from the Twitter. I see some Twitter account to share some latest malware samples. So that's why also how to set up your database with the malware samples for similarity analysis.
Yeah, so you can see for instance response, it doesn't mean that whenever there's incidents, then you do things. You need to prepare first. Otherwise, you cannot do things fast. Okay, so besides the backdoor file, you also want to look at the backdoor server or some server that you think that is under attack or being compromised. So how can you check whether the server is compromised? Usually, you can compare the configuration file, which is also suggested by the experts. So you need to first prepare the golden copy of the configuration file. So that's the original copy, and then compare it with the deployed one. But yeah, Alan, I think you also do this and you found that the server is still suspicious. Why is that the case?
Yeah, normally, of course, a golden copy would be the best idea. However, as you can see from our case, the engineers thought that it was the golden copy. But however, the configuration file was actually corrupted. So whenever they try to restore the new servers from the golden copy, they actually restore the infected things as well. As you can see, the configuration file is actually loading the malware as well. So for this case, it cannot be done by just simply comparing the configuration file. It would not be sufficient. Yep.
Yeah. So that's one tricky point you may want to be aware of. So especially when you have these insiders doing bad things, right? And the other point would be you also want to examine the activity and the error logs of the headed server to detect whether there's some successful or failed external program or modules. And we also want to dump the volatile memory in some cases. So for example, if the backdoor server is doing some very stealthy operations, like after they start up the servers, they have another fileless malware plant inside the server, then in that case, you need to dump the memory to do the analysis. But I think in our case, we didn't do this because the backdoor is planned on the IIS module. And then after that, once you identify the backdoor server, you can continue to do the string analysis to identify more suspicious string and commands. So last but not least, you also want to look at the network traffic. So first, you want to identify what is the normal traffic patterns, like doing the benchmarking on the common request and response headers. And then you can also look at those traffics with suspicious pattern, like a high volume or from IP address that is not popular. But you can see that the prerequisites of doing these tools activity is to have an SIEM, right? So Alan, what if we don't have an SIEM in the organization? What should we do?
Yeah, back to a few years ago, there wasn't any SIEM. So by that time, we just export all the logs from the Windows server and the SSL VPN log from the firewall devices. So we could read the logs, but it took much time.
Okay, yeah, so that means you need to drill down to each server to look at the logs instead of having the centralized SIEM to view the log and do the analysis quickly, right? So you can still do the investigation and instance response, but yeah, it's slower. So that's why be better prepared before the incidents come. And after that, once you have identified these suspicious traffic, you can write another network traffic search rule. So I think we already have Java rules before for the backdoor. So Anthony, why do we want to have a network traffic search rule?
Well, first of all, actually, Ken told me that the rules is written by the people. And if you depend on someone write the rules, then you will miss some important points. So that's why you need to check it out different patterns by yourself to manually to review as well, to set up your own rules or write your own rules to detect it based on the backdoor or some kinds of business logic or on business context, or for example, some specific keywords or some specific functions or label, variable names, you need to make it. Otherwise, if you simply just take other one rules to detect it, sometimes you miss it. So that's why we need to draft our own rules.
Yeah, so that's why we propose so many different steps in here. One major purpose is to triangulate. So because whenever there's some indicators, that doesn't mean that it's a backdoor or not, right? You need to have multiple incidents of evidence to see whether it's positive or negative. And of course, if you are capable enough, you can also do the network traffic decryption or the obfuscation, especially if you have a complete analysis of the malware. Okay, in conclusion, we have discussed this realistic case, and based on this case, we propose a playbook that integrate different existing solutions, and we also propose algorithms and incident response matrix to help the practitioners to do a faster instance response. So in this case, actually, the typical IR is still useful, but yeah, maybe not for the backdoor. And some experts also suggest we have this comparison of the configuration file, but yeah, sometimes it didn't work because of the insider. Okay, that's all for the presentation. Thank you for your attention. And I think we are running out of time, right?
Thank you so much, you guys. Then sorry for we can't attend it, but hopefully we can make it next time.
Yeah, so I think we are running out of time. So in case if you have any questions or comments, please feel free to post on the virtual platform, the swap card. Thank you.
Thank you, guys.
Thank you.